Hi everyone, this is Mrs. G. Today we're going to learn how to graph sine and cosine with the transformations of stretches, shrinks, and reflections. So first we're going to start by looking at the parent functions for sine and cosine. So the parent functions can be created by simply creating a t-chart with a table of values that we know how to fill out and plotting our points. So we know, for example, that the sine of 0 degrees is 0, the sine of 90 degrees is 1, the sine of 180 degrees is 0, so on and so forth. So we can see that we have this graph, and it actually repeats in this kind of wave shape going to the left and right. It repeats infinitely. And then cosine looks very similar. It makes that same kind of wave shape, but you'll see on your y-axis, it actually starts here at 1 because the cosine of 0 degrees is 1, and then 0, -1, 0, 1. So a few key features of our sine and cosine functions. First, the period of both of these functions is 2 pi. So if you're wondering what is a period, look down here at our trigonometry vocabulary. By definition, the period is the length of one complete cycle of our graph. So if you look, if we go from 0 to 2 pi, for sine, we have a full hill and a full valley, and then from there, it would just start repeating. And you can see going backwards, it just repeats. So it takes 2 pi, or 360 degrees, to complete a full cycle. So for our parent functions, for both sine and cosine, the period is 2 pi. So you can see the same thing for cosine. We're starting at a maximum, and then by the time we get back to that maximum value, it's been 2 pi, or 360 degrees. The next key feature of both of these graphs is what's called the amplitude. So the amplitude, if you look down here, is defined as the distance from the midline of your wave to the maximum or minimum values. So if you look at both sine and cosine, right, here's our midline. The distance from that midline to the maximum is 1, or from the midline to the minimum is 1. So same for cosine, the distance from our midline up or our midline down is 1. So notice it's not the very top to the very bottom, it's from your midline to the top or to the bottom. Okay, so for both of our parent functions, the amplitude is going to be 1. And then here we have some key points listed out for each of our functions. So I'm actually always going to use these same 5 key points to help us graph, and we're just going to simply transform our coordinates whenever we have any transformations. So for sine, we're going to pick 0, 0, pi over 2, 1, pi 0, 3 pi over 2, -1, and 2 pi 0. So notice that I kind of have like the 4 quadrant angles, well, 5 quadrant angles from 0 to 2 pi. And then for cosine, we have 0, 1, pi over 2, 0, pi -1, 3 pi over 2, 0, and 2 pi 1. So those are the 5 key points that I'm going to use to transform our cosine graphs. So we're going to start again with our key points, and then we can transform the coordinates depending on what we see in the equation. So for transformations of our sinusoidal functions, which would include both sine and cosine, you're going to notice that these transformation rules are the same that we've been working with all year for any function. You'll see that there's maybe a plus or minus sign out front, there's an a value out front. We can add or subtract h from x, and then we can add or subtract k from our entire function. So the rules are going to be the same. Anytime you see that a value, which would be a number multiplied to the front of your function, this represents either a vertical stretch if a is greater than 1, or a vertical shrink if a is between 0 and 1. And really, the trigonometry term for this would be an amplitude change, because it changes the distance from your midline to the maximum or minimum, because it is a vertical stretch or shrink. How do we apply this to our key points? We're actually just going to multiply all of the y values by a. And again, we only do this to the y values because it's a vertical transformation. Now the plus or minus sign out front, really you wouldn't see a plus sign, but you might see a minus sign out front. So if you ever see a minus out front, it represents a vertical reflection, and we can apply that to our coordinates by simply multiplying all of our y values by -1. And again, we only do it to our y values because it is a vertical transformation. Okay, next, what happens if we add or subtract from x, so that value we always call h. So let's look right here. So if you see plus or minus h here, that's actually going to cause a horizontal translation, which really is just a shift to the left or right. The trig term for this is actually a phase shift, but it just means we're shifting left or right. And we can do this, we can change our coordinates by simply adding or subtracting h from all of our x values. Again, this time we only do it to our x values because it's horizontal. And I want to remind you, due to that negative here, this actually moves in the opposite direction that we think. So if we actually see plus a number, it moves to the left. And if we see minus a number, it's going to move to the right. All right, and our last transformation is what happens when we add or subtract to our entire function. So that k value is going to cause a vertical translation. So it's going to shift our graph up or down. And we can apply that to our coordinates by simply adding or subtracting k to all of our y values. So again, this only affects the y values because it's a vertical transformation. All right, so we're going to try graphing a couple together. So for each of these, we're going to graph 2 full periods of our function with at least 5 exact coordinates from each period. And then we're going to determine what the period is, the amplitude, and the maximum or minimum values. So since it's sine, we're going to start by listing out our 5 key points for our sine graph. So I'll do that here. So we have 0, 0, pi over 2, 1, pi 0, 3 pi over 2, negative 1, and then 2 pi 0. And if you do this enough time, it gets really easy to list out these 5 coordinates. So what do we see here? We see the negative out front, which means it's going to be a vertical reflection. So it's actually going to reflect over the x-axis. So what we're going to do to cause that vertical reflection is we're going to multiply all of our y values by negative 1. So we're going to do times negative 1, again, just to the y values because it is a vertical reflection. Okay, so let's see what that gives us. So this gives us 0, 0, that stays the same. And then pi over 2, negative 1. Pi 0, that's unchanged. 3 pi over 2, positive 1. And then 2 pi 0. So we can plot those points, and that should be our new graph. So we have, again, 0, 0, pi over 2, negative 1, and I'm going to change the scale of our y-axis. So 2 tick marks is 1, so this is 1/2 1. So if we have pi over 2, negative 1, that's here. And then we have pi 0, 3 pi over 2, positive 1, and 2 pi 0. So this is one full period of our graph. And you could see, if you remember what our parent function looked like, I'm just going to sketch it with a red dotted line. This is what our parent function looks like. So you can see that it was actually that reflection over the x-axis. So vertical reflection over the x-axis. So here we have one full period. We can actually just continue the pattern moving off to the left. So you can see that the pattern is it goes from the midline down, midline up, midline down. So it will repeat that pattern. So moving backwards, we go to negative pi over 2, and then we can go up to positive 1, and then back to the midline, and then negative 1, and then back to the midline. And notice we're counting by every pi over 2. So there's our second full period of our graph. And this would continue on going both directions. So the amplitude of this graph, remember, is just the distance from the midline to a max or minimum. So it's still 1. That was not changed. The period didn't change. The period is still 2 pi units. And the maximum value is 1. And the minimum value is negative 1. So that was also unchanged. All that is different is that we had that vertical reflection. Okay, let's try another one together. So here we have a cosine graph. So we're going to start with our 5 key cosine points. So we have 0, 1, pi over 2, 0. And then we have pi negative 1, 3 pi over 2, 0, and then 2 pi 1. So let's look at our equation and let's see what our transformation is. So you can see here that we actually have a vertical shrink by a factor of 1/2. So I can apply that to my coordinates by multiplying all of my y values by 1/2. Again, we only do the y values because it's a vertical transformation. So that leaves us with the coordinates 0, 1/2, pi over 2, 0, pi negative 1/2, 3 pi over 2, 0, and 2 pi 1/2. So again, the scale of my graph, I'm changing the y-axis. And let's plot our points. So we have 0, 1/2, so right here, pi over 2, 0, pi negative 1/2, 3 pi over 2, 0, and 2 pi 1/2. So our graph looks like this. And it would continue on, and we can continue that same pattern to the left. We go midline, minimum, midline, maximum. So it looks like this. So if you compare this to what the parent function looks like, so the parent function looks like this, you can see that it is simply a vertical shrink, right? Our graph isn't stretched out side to side, but it doesn't go quite as high or quite as low. So our amplitude is unchanged. It still takes 2 pi radians to complete a cycle, so it's still 2 pi. Sorry, our period is still 2 pi. But the amplitude has changed. So instead of having a distance of 1 to the max or minimum, you can see that the distance is 1/2. So really that a value is always going to be our amplitude. So our amplitude is 1/2, and the maximum value is positive 1/2, the minimum value is negative 1/2. Okay, so at this point I'm going to ask you to pause the video and give this one a try. So we have negative cosine of x. So make sure you're starting with those 5 key points for cosine. And we'll check our answers in just a few moments. Okay, let's check our answers. So here you can see that we have a vertical reflection. So it's going to reflect over the x-axis. So that's why we multiplied all of our y values by -1, giving us these points to plot. So our graph is in black. And you can see I graphed the parent function in dotted red just so you can see how that vertical reflection actually looks. Our amplitude is still 1, the distance from the midline up or down. The period is still 2 pi, that's how long it takes to complete a full cycle. And the maximum value is 1, the minimum value is -1. Okay, here's our last problem for today. So again, start with those 5 key points for sine. Pause the video, give it a try on your own, and we'll check your answer in just a few moments. All right, so go ahead and check your work here. So here's my original key points. Because we have that vertical stretch by a factor of 4, I multiplied all of our y values by 4, giving us these 5 points, which looks like this. Again, the scale of my y-axis is now just counting by 1. So you can see if you compare it to what the parent function would look like, you can see that it really has just been stretched out vertically. So the hills have been stretched up, the valleys have been stretched down, but you can see like all of the x-intercepts are still in the same place. So our amplitude, again, the distance from the midline up or down is 4, which matches that a value. The period is still 2 pi. And the maximum value is 4, and the minimum value is -4. All right, so that is all for today's lesson. Thank you so much for watching.